Mhm. Okay. Okay. Thanks for inviting me to give this talk. So the topic today is engineering practice of data science in transportation and logistics. I think the purpose of this talk is to share some of my experience in the transportation and logistic industry. I think the purpose is to, how to say, give everybody some sides on how can we better leverage the data science in the practice. So I won't go deep dive into the technical details, but instead I want to share some experience. How can we connect the data science with business success? So I think this is the purpose. The table of contents today, I will first introduce the data science ecosystem and also introduce some methods, skills, and most importantly, some tips, like when we are doing our work, and share some business insights about the transportation and logistics to share everybody how they operate their company, operate our logistics network, and share some kind of tips about end-to-end development. So the last session is a QA, and I want to make this talk interactive. If you have any question, you can interrupt me anytime. So um, let's go ahead. So the basic definition about the data science or analytics. Uh, sorry, where is the mouse? No. Okay, 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 it's fine. So the basic definition about data science or analytics is using scientific methods to convert the data into better business insights and decisions. As we can see, it consists of three parts. Scientific methods. What is scientific methods? To be specific, just modeling and algorithm techniques. Statistics, machine learning, optimization, and simulation. What is data? Data means we need to proper way to process our data, and be more specific, just computer science techniques, like the object-oriented programming, database skills. And what is business success? Business success means you need to have some solid business understanding. Otherwise, you don't have proper way to identify opportunities. That is business success. And so we need the proper way to analyze our business, and we need to perform the end-to-end development, and we need better communication skills with our stakeholders, business partners. So I will go through each one today. Let's first look at the analytics ecosystem. When we are talking about analytics or data science, actually we have three types of analytics in practice. The first one is descriptive. So we should first understand our business, like what happened for our business. Did we perform good or not? So this is the predictive. On top of that, we need to predictive. So we are not only trying to describe our business correctly. We want to have accurate prediction about the future, which is predictive. And on top of our predictive, we need to perform a prescriptive. Prescriptive is to formulate some optimal strategy for our business, which is what best can happen. So we need to we are not only trying to predict what's going to happen in the future, we are trying to, how to say, guide the business to the best future. And after the tomorrow, we should go back to describe it again to see if it is like prescriptive by our methods. So these three parts form the business analytics ecosystems, and the core is data and the business. So there is a maturity model, which is quite common in the industry. As we can see, descriptive analytics probably is the most easy one and kind of the foundation. And the prescriptive one is quite difficult in the future. It's really hard to be implemented. So be more specific. Here are 4 types of methods: statistics, simulation, optimization, and machine learning. I will go through each one. Again, I won't go through a lot of technical details, and I will use some use cases to show how could we connect our techniques with business. Let's first look at the statistics. I think everyone has some understanding about what is statistics. I think there are a lot of definitions, but from my experience, I think in industry, the statistics is to prove significance when using data to describe business. Again, look at the significance. So I can share one story. When I was at the JD.com, I'm leading the data scientist team to design the logistic network, optimize the operations. So one day, one of the stakeholders reached out to me, told me, say, okay, in the usually our on-time percentage, which is a service level agreement. So usually the on-time percentage was like 95%, 95%. But today it drops to 89%. So he thinks probably this is unusual. This is quite abnormal. So I returned a question. You think 98 is abnormal? What about 98.1? What about 98.2? So we, how to say, we admit that the fluctuation is unavoidable. Fluctuation always happen, but to what degree, we couldn't say it's a normal deviation. It's definitely abnormal. So we need the statistic method to identify the abnormal. Let's look at the chart. We imagine that is the on-time percentage. When we deliver our package, we will have on-time or not. But we deliver like 100 packages, we will have on-time percentage. So this is the on-time percentage. Imagine this is on-time percentage every day. And we can see some of the dates is out of the upper or lower bound. So this should be identified as the abnormal. So we really need to this is called the statistical quality control method to identify the abnormal, significantly abnormal. It's not saying intuitively say, okay, I saw it's go up, so it's abnormal. So we do need some techniques to draw the conclusion. Let's look at the second one. I mean, I don't want to go too deep about the statistics. Let's look at the second one, which is machine learning. Machine learning, I would say it's trying to recognize some patterns in the business to facilitate better decisions about the future. So we learned some, like for example, customer behaviors or transportation operations, and we recognize some patterns, and we want to utilize those patterns for our like future prediction. So this is how machine learning used in the industry. I categorize this in 4 types of machine learning. The first one is segmentation. And second one, correlation, association, and time series. So for the segmentation, sometimes we also say it's like clustering. For example, when I was at the JD.com, we owned like 1,000 superstores nationwide, but it's kind of impossible to formulate diversified optimization strategy for each one because we don't have so many human resources to do that. And we cannot, sorry. And we cannot saying like we don't want to differentiate our stores. We want to come up with one integrated plan for all of those stores. That is meaningless. So we have to cluster all those stores into different clusters so that we can like formulate our strategy for each cluster instead of for each store. So this is the segmentation. Correlation is quite intuitive, and this is most used in the industry, like regression. And the classification is the correlation analysis. For example, the customer churn prediction. Have you heard about the customer churn prediction? For example, you are the credit card users and you are going to cancel your service. So I can predict you are going to cancel your service. And I can kind of give you some deals or discounts in advance to retain you in my system. And we know finding a new customer is much more expensive than retain an old customer. So we need to do the prediction. So then we can take actions in advance. The association analysis is to see if two events or items occurred together. The most famous example is beers and diapers. Have you heard about it? Beers and diapers. So for example, this is quite original in Walmart. And after analyze the transactions or the shopping transactions, we found that beers always sells with diapers. So we put them together to increase the probability to sell both one. So that is quite common. And in the transportation part, actually this is also quite often used, especially in the maintenance. For example, when we maintain the one part of the railroad, like traction motors or locomotive parts, but in the next like 30 days, we have another parts get kind of damaged or defect. So we should, at each time, we are not trying to repair the default one. Probably we need to do something more to decrease the probability of risk. And time series forecasting is quite straightforward. We are going to forecast our demands in the future. That is, for example, in the replenishment. Have you heard about the replenishment? Replenishment. So in the retail, we have to prepare our inventory for you to buy the products. For example, if you go to superstores, so they have already prepared some inventories. But what's the level which they should prepare? It's called a stock, safety stock levels. So it's based on our forecasting about the future demands to prepare some like products. Let's look at the example I previously showed in the statistics. We have the on-time percentage, and we already know it's quite through some statistics method. We identified one is sorry, it's kind of, and hey, what's going on? It's frozen. Okay, anyway, so we have identified one of the points is abnormal, but it's not sufficient for us. So it's not enough for us. We want to find the root cause. Why it is abnormal. And we identify this data point as positive, as others as the negative. So we identify this data points as positive samples with some features like the demand today and kind of the traffic information or capacity information. All of those are treated as features. And we defined a lot of negative samples, which is normal. And we build up, this is a decision tree model, so we can identify why it is abnormal. This is trying to find more insights about the on-time percentage. Here is some tips that is quite interesting. I think this can give you a lot of that kind of insights if you go into work in the future. How do you argue with your managers? This is quite interesting. So for example, when we build up a forecasting model, how do we evaluate its performance? So your manager asks you to build a predictive model, and you did it. How do you evaluate your model? Definitely, we can say from technical side, we can see the accuracy. The more accurate your model is, we can say you have utilized the better techniques, or you have more advanced method or whatever we can say the performance better, outperform the other method. Definitely, this is from the technical side. But this is a very important tip. Think about the forecasting. If your manager asks you, hey, hey, Yuan, please promise me you can make the accuracy to 95%. Promise me. So never trying to make such a commitment because this is out of your control. This is controlled by the data, by the business. It's not out. It's out of your control. You are trying to try your best to improve the accuracy, but you can never promise accuracy. This is not a technical issue. This is a business issue. Instead, what you should do, you should focus on the business performance. Let's look at the replenishment problem. You need to predict the future demands. But why do you want to predict the future demands? It's not saying you want to improve the accuracy. The ultimate goal is trying to improve your revenue or reduce the inventory. So your goal should focus on either improve the revenue or reduce the cost, which is the inventory. This is something you can like make a commitment saying, okay, I set up a goal. I trying to improve how many percent about the like revenue or something. But again, this is not controlled only by your prediction. This should cooperate with other methods such as optimization or something else. But again, this is quite important for any forecasting or prediction model. Never trying to make a commitment about the accuracy. Sorry. Sure. Mm-hmm. Mm-hmm. Yes. 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 Yeah. So this is a really good question. For the first one, for the like kind of for the forecasting, we can set up the baseline. Right. This is kind of easy. If we tried some method, we know okay, this is a baseline. This is easy, but we never know the upper bound, so we cannot promise the upper bound. Yeah. So this is, if I understand your question, it's quite easy. We can set up a lower bound, but we can never make a commitment about the upper bound. And the second question is quite interesting. Like you say, we are just the modeler. We are not the business stakeholder. We don't own the business. It's quite out of our control. So the best way from my experience is not trying to make a commitment by yourself. You should cooperate with different, like you say, the steps or different business partners. So we formed a team and we can eventually say, okay, we set up a goal. But by our data science individual, it's really risky. You set up a goal by yourself. For example, I work with, in a railroad, I work with the transportation department. So after working with them like half a year, we understand each other quite well. And they have confidence that if you provide any techniques, they will do some reform about the management, or they will like improve their operations as long as you provide some techniques. So by that way, we can work together to pursue a goal, not only by myself. This is quite important. Never trying, we are just a tiny data scientist, never trying to make the business commitment by yourself, but we should work with other partners to do it together. Okay. Can I continue? Yeah. So the third example is a simulation. Let's start from a like interesting animation to understand what is the simulation. Have you heard about the predator and the prey problem? Let's first look at. So in the system, we have the grass, like it takes 30 days to grow up. And we have if if the wolf eat a sheep, it will increase 20 energy. And if the sheep eat like the grass, it will increase 4. You will consume 5 energy. And for the sheep, it will consume 4 energies. Initially, we have 50 wolves and 100 sheep. Let's see what's going to happen for the system.
I think the mic shut off.
Sorry? Oh, okay. Okay, so we can see the ecosystem is balanced. So we can see the population of sheep increased, but with the population of sheep increased, for the wolf, they have more food to eat. So the wolf's population increased, which resulted in the sheep population decrease. And after the sheep population decreased, it's more competitive. Yeah, it's competitive for them to seeking food. So the wolf population decreased. I mean, that will go forever. That will be balanced. Let's make a small change. We make their kind of, this is the food of the sheep. We make it grow faster. See, the grass grow faster. So we have 4 possible things. We have more sheep in the system, or we have more wolves in the system, or we don't have any wolves, or the world is destroyed, so no one can survive. Let's imagine one. Let's like please pick up one. I really want to make interactive.
More sheep.
Okay, some people select A. Yeah. So again, for example, this is not quite intuitive to answer it. So it's really like this is why we need a simulation. Let's look at what's gonna happen through a simulation. See, the sheep population increased quite fast. You can see it, and the wolf's population increased because they have more food. And what happened later? So sometimes for the wolf population, it increased too fast. It will result they don't have any food and the world is destroyed. So this is called what if analysis. What if the food of sheep grows too fast? This is called what if. This is really great tool in the industry. Okay, so the definition of simulation is use computers to perform experimentations for business. I can share you 2 examples. So, oh, sorry, I forget to translate it. So, but anyway, look at the time. Yeah, so look at the time. So, in the logistical warehouse, we have a very important process called ribbing. Like in what is strong binding and weak binding? So I mean, in a very simple way to explain it. So the strong binding is you only focus on your own work. After your work is done, you are just wait there for new tasks. And the weak binding is you after when you are free, you are going to help others. So of course, from the management perspective, the strong binding is easier. So we don't have to modify the system. We don't have to design the information system. We don't have to kind of change our way to measure their work. So this is kind of easy. But we realized that the workforce is underutilized. So we really want to investment. We will invest to upgrade our system and the management. But again, any investment, we are looking at the return. So let's say if we want to change the way they are working, what's our return? And this is what if, what's the return if we change the management? So look at the date, look at the time. From the traditional strong binding way, they have to finish all of their work until 11 p.m. But if we change it to the weak binding, it can finish all their work at like 6 p.m. That is a quite significant improvement. It's worth to invest or the new techniques or new management. So this is what if. And of course, for the simulation, it has some other like use cases. For example, the first one is to the verification. Have you heard? Probably, you know the Black Friday in US, but in China we have Double 11. So every year that is really a big challenge for kind of internet giants because they have huge peak demand volume. So we have to, in order to, how to say, deal with such a huge volume, we proposed many like strategies or plans, but we have to verify it. We use simulation to verify if our logistics can cover such a high demand or if our workforce is enough or kind of things. This is called verification. And second one is training. For example, for the aircraft or like the train dispatching, it's not going to give you real planes or trains, locomotives to train new dispatchers. It's quite of risky and expensive. So we developed a room like called a training center for them to train. And this one is also very how to say, like frequent used method to determine the capacity, which for any, I will cover later why the capacity is so important in transportation. So we really need to understand our capacity. Okay, so let's talk it later. And this one is simulation plus optimization or simulation based optimization. This is one of the advanced methods. So I don't want to go to so many deeps about it. Let's look at animation. It's quite funny, fancy. It's really fancy. Yeah, you have 3D and 2D animation. Yes, one of the advantage of simulation, it comes with excellent animation. It's very good to present to the senior leadership. Yeah. So okay, look at the again. Simulation is a great tool when. So from technical perspective, if we have stochasticity or uncertainty, it's really hard to formulate it. So we rely on simulation. Uh, and for some complex system, so it has too many elements and the structure is so complicated, we rely on simulation to describe the system. This is from technical side. And I focus on the business perspective. When do we need the simulation? The first thing is when we want to tell a good story, we want to present it to the senior leadership. I think simulation with animation is really, really kind of like straightforward for them to understand your efforts and understand your instructive findings. And the third case we rely on simulation is a third party. I can share you another example. When I was in the railroad, so one of the yard masters said, okay, our capacity is 100 trains per day. Throughput is 100 trains. And his manager didn't agree with him. So his manager said, okay, I was a yard master. I understand how yard operations. I think it is supposed to be 120. And they can make agreement. They can make agreement. So they reach out to me, say, okay, Yuan, you are the third one. You are the third person. Can you do a simulation to prove who is correct? They reach out to me. So I'm the third party. I trying to be fair on their kind of argument. So I developed the simulation to tell them the actual capacity is supposed to be 110. So none of you are correct. And the third one is provide scenarios. For example, we haven't built our warehouse, but we want to try some management improvement. We don't really have a real warehouse, but we still want to try some optimization strategy. So we have to rely on simulation to do it. Otherwise, we don't have really real use case for them. The first one is optimization. Optimization goal is find the optimal or near optimal solution from millions of billions of feasible business solutions. This is optimization. So it has three levels: strategical, tactical, and operational. So first, for the strategical, I just come up with a question for everybody. Do you think we really need OR tools, optimization or data science tools, to make a strategical decision? This is just a question. And the tactical, I gave some examples like crew scheduling or the network planning. Operational level is real-time dispatching or pricing or vehicle routing. Let's come up with three examples. For the facility location, it's definitely strategic because all the decisions for long term, we don't change it frequently. And say we have a lot of demands and we have a lot of candidate points. So the blue circle is the candidate hub, and we are trying to design one road from our inbound hub through our candidate hub to the outbound hub, and we will try different paths. Oh, sorry. And we can say after we try all of these possible ways, we only select two parts. So for most strategic problem, actually they are trying to find a balance between LSA and cost. What is LSA? Service level agreement. For example, in our case, definitely we want to maintain the highest LSA is to invest as many hubs as we can. But this is not cost efficient. We will sacrifice a lot of cost. And definitely, if we only invest one hub, that is the minimal cost. But we will definitely sacrifice our service level agreement. So for most strategic problem, it's trying to find the cost and service balance. And in reality and in practice, actually, most strategic problem is not a scientific problem. For example, if I want to build a hub in Tampa or in Gainesville or something else, the biggest problem is you need to negotiate with local government or local authorities. You first need to get the land. It's out of our like OR methodology. The second example for the technical one, I can give you one is like train crew scheduling. Let's first understand what is a timetable. We have the train from SH to JN, like 9 o'clock, and arrive at JN at 10:30. This means we wait half an hour, and we let this train go to BJ at 12 o'clock, and wait a while, ask this train to coming back to SH. This is a timetable to describe the time and the space movement about the train. So the crew scheduling is trying to find the crew path. What does this mean? This means the crew stayed at JN, but the train, some other crews drive the train to next station. And the train come back, and the crew come back. So we have such a crew path. And the crew scheduling problem is to, plan minimal number of passes to cover all the time space. So why this is be category be classified into the tactical, because this is not a really long-term optimization problem. So we are going to change it every month or every 2 or 3 months. And this is not the operational, because we are not going to change it every day. This middle term operations. So last example is operational one. Let's look at the gate assignment problem. Think about what is dispatching in the transportation, because for most of the transportation problem, we are not trying to optimize the operation from scratch. We are trying to optimize the operations from our plan. So let's look at the, like we have some flights and we already signed their gates. For example, the UA888 was assigned to gate 8. Okay, so after, oh, sorry, forget, sorry, okay. So at 8 o'clock, we received the notice that the CA9537 will be delayed. And we see a conflict. This is the original plan, but our operational target is trying to change this plan. How do we dispatch it? So we move it to different gate, and we move it. Okay, we come up with new feasible plans. Rescheduling or redispatching, that is the most frequent cited problem in the operational level. Okay, some tips about optimizations. In transportation or logistics, when we are talking about optimizations, mostly we are talking about deterministic mixed integer programming problem. Here are some tips. I don't really want to go through each one, but I want to select some more highlighted. So the first one, if we want to optimize something, what is the easiest way? You should first mimic how people manually do it, mimic it. And then you find some good opportunity to optimize it. And importantly, enhance your programming skills. So again, I don't really want to go too deep about the techniques. Here, I want to share some business insights about how do we better utilize our data science techniques. That is quite interesting. So from my 10 years experience, I realized that each industry has a very important cornerstone. What is cornerstone? Which means if you can do it correctly, you will never be a champion in your industry. So for example, for finance, whatever your finance product, how good it is, whatever your finance product is, and whatever your service is, the first thing you need to do is control your risk. Otherwise, you will get bankrupted for sure. So this is the most cornerstone for finance. And for the healthcare, what is the cornerstone? Is safety. So I think the baseline is you never want to, kill your patients. You never want to bring new troubles for your patients. So for the healthcare, it's safety. And for the retail, it's called merchandising. So what is merchandising? Merchandising means you buy products from your vendor and you sell products to your customers. But what do you buy from your vendor? That is merchandising. So this is think about why do you go to Walmart? Why do you go to Target? Why do you go to Publix? What's their real difference? Although they have different decorations or have different, service, different price, but I think the real difference is they have totally different product. Although they have some overlap, but some key products make you determine to go to Walmart or Publix. So that is called merchandising. So for any retailer, if they don't focus on merchandising, no matter how fancy their service is, no matter how fast it's delivered to your home, they're gonna to die. They're gonna to die. But think about it for transportation and logistics. What's the cornerstone for these two industries? Cost and time, maybe. Good, this is one answer. Any other? Let's look at what's the essential difference about the logistics and the transportations. This is part of my understanding. So very importantly, if I was in the transportation company in the railroad, and I was also in the logistical company, I realized there are essential differences. They are selling totally different stuff. So this is called the product difference. For the logistics, actually what they are selling, they are selling their promise about the time. It's called time efficiency. So for, as JD.com, we have a 211 policy. Like have you heard about it? 211, which means if you place your order before 11 a.m., I will deliver your order to you by the same day. And if you place your order at 11 p.m., I will deliver your products to you in the next morning. So we have two important promises. So all our work, our network design, our kind of capacity assignment is to achieve our promise. But when I was in the transportation industry, what we are selling? We are selling our cars. We are selling our possible capacity. For example, for one train, we have 50 cars, but we are selling some of them. And we don't, although we have some proposed expected time promise, but this is not the most important part. So we don't really have kind of promise about our time. So this is, I think this is the essential difference. They have totally different products to sell. So the second difference is as about the assets. I think that for the logistic one, they have kind of lighter assets, and for the transportation, they have heavier assets. This is in the one of the difference. And for KPI, as we know, logistics is trying to make their promise. So what do they really look at? The on-time percentage, the promise we made. So, and as we know, for the transportation, we are selling our capacity. So we should really look at the asset utilization. What's our train utilization, our flight utilization, our car utilization, truck utilization. So for the network design, it's quite interesting. When I was at a logistics company, they designed their network based on their product. We have 211. One of our product is called 211. So we have a specific 211 network, and we have like overday delivery. Another, we have overday network, although they have overlap. But again, because they are selling the time efficiency, so they have to design the network to match their goal. But for the transportation, definitely this is asset network. We have tracks, we have our hump yard, we have our hub, all of those things, infrastructure. Even more interesting for the organization. So, I mean, I'm not sure if you have our work experience before, but if you are going to a new company, especially for some giants, like large companies, I think the first thing you should do is to review and check the organization chart to understand how do they organize their teams, because it provides a lot of insights and clues about the company goals and what they are selling and what they are trying to achieve in the future. So I can tell you for transportation part and the logistic companies, they have totally two different style about the organization. For the logistic part, so they organize all the teams based on their product. Like 211 has a 211 business group, overday business group. Again, so they are trying to achieve the time efficiency. This is why they organize the teams using this way. But for the transportation part, actually they organize all the teams based on capacity, like locomotive department, car department, maintenance department, engineering department. All of those is facing their, is the capacity oriented, is their asset oriented. So they are quite different. It's quite interesting. And look back, what's the cornerstone for transportation? Definitely should be the capacity utilization, because they are saving the capacity. And what's the cornerstone for logistics? Time efficiency. So if you are operate a logistical company and you don't have any time efficiency promise, you're gonna die. But if you run a transportation company, you don't have time efficiency promise, I think it's okay, as long as you have better capacity utilization. So the last part is under development. So how do we better leverage the data science? We start from business. Again, start from our understanding about the business, understanding about the opportunities. And we utilize the model and algorithm, which is data science part. And we rely on engineering team, computer science, software engineers to make our models into applications. And we need to first evaluate our tech. For the forecasting part, you should evaluate the accuracy. If you come up with a good accuracy, but it's not enough. We should also evaluate the operations. It's called ops evaluation, because we want to start from business and end to the business. So I I I I saw a lot of teams. They start from the business, start from requirement, but end at the technical evaluation. It's totally not enough. So they say I want forecast the demand. So I give you a better forecasting, a better prediction. So what? What's the business impact? And we will really look at the business impact. I think this is all I want to share to everybody. Thank you. Thank you. Sure, if you have any questions for online folks, please. I think I have to. They can unmute it directly, right? Okay. It will be fun to are to compare the performance of ground roads to UAM roads. The organ delivery is one of the drivers for AM because the very small window for reach time. Okay, I agree. I would say. Any other questions?
So that customer churn prediction, is that like when you talk about things and then you get on social media and all of a sudden it's there, like an advertisement? Like if I talk about like ice cream and then all of a sudden I get on like Facebook, there's like an advertisement for like ice cream.
The ice cream.
Or just like it, no, just like for an example, like if you just say something, I don't know if like if your phone hears you or something, but if you get on social media, there will be like advertisements for,
yeah.
you know what I'm talking about?
Yeah, I understand. Yeah. So customer churn prediction is quite it's a really hard topic for social media and company and the finance company. Again, although it is not quite frequent used in our transportation or logistic company, but for the Facebook or Twitter or something, they used a lot of customer churn prediction techniques. As long as they identify this customer has, some risks to leave their service, to stop their service, and they can take action, such as advertising or some coupons or something else to retain the customers. Yeah, it's quite common. It's quite common. I think there are some specific study areas focusing on customer churn prediction. Yes. Uh, yeah. Yeah, but you can see 3U1314 has overlap with AA5527. So we have to first switch here, and but we can see 3U1314. Yes, 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 yes. Somehow they knew that customer would. Somehow Amazon knew that customers would daily data with same day delivery. How is the factor inputted into OR models? I'm not sure if I understand the question correctly. I think, let me repeat it a little bit. You are saying somehow Amazon knew the customers um, has some expectation about the same day and has different expectation about the like overnight or something. Again, if we want to put this factor into our OR models, just give different penalties or some like objective function parameters. I think this is case by case when we are trying to build our models. Yeah. Mm. Or extra. Yes, yes. Yeah.
I mentioned it could be case by case, depending on what kind of customer you are, what product you order, and then they will, so the penalty is like, if in the OR, basically, they add something in the objective function, saying if the solution cannot meet the same day requirement, then it will be penalized. So by doing that, it actually lead to more the optimal solution that could meet
Yes, yes,
the same day delivery.
yes. So if we cannot make our promise, we will give some penalty, as like some cost for us. Yeah. Mm.
So like it could happen, for example, due to hurricane season or there's some natural disaster. And that happened before in the US, right? Because of the weather problem. Actually, if you order something but they couldn't deliver on time, in that case, from the JD.com, during your work experience there, have they how to say compensate the customers, or what are the strategies that they do to maintain the loyalty of the customer?
Uh, so so first of all, if some like extreme cases like the disasters or extreme weathers, first of all, the customer is understandable. This case is understandable for customers. This is quite. We want to say, as long as our try our best to maintain the loyalty or maintain our promise. Uh, to be honest, the customer can feel it. This is the first thing. And another very important topic is we really need to manage the expectation of customers. As long as we identify, okay, this is not operational problem. This is some extreme cases like disasters, and we should first downgrade our promise. But most importantly, we should like inform the customer, yeah, to communicate and let them know. And so this is why I share one of the example about the delay awareness. So we need to, actually, I have one publication about the delay awareness. So it's not gonna detect the delay when it happened. So it's already too late. We should predictively identify if delay happened and inform the customer. I mean, for most customers, if you informed me, I think it's more like understandable for them. But if you just at the last minute to let them know, they will feel really bad about that. Mm-hmm.
Risky
Mm-hmm.
to take the risk of getting there in time. Sometimes it causes crashes and fatalities. So I don't think that's necessary because honestly speaking, from the customer's perspective, if you're expecting your food, what's the difference between 5 minutes? What is the difference of 5 minutes? Are you gonna die from being hungry? Right?
Yeah, yeah. I,
Yeah.
I totally agree because now I'm leading the Walmart last mile delivery group. So I think one of the things I really want to share with, um, we really need to diversify our promise. Not always like when I was in JD.com, we always make the really strict promise. So it's really kind of sometimes it bring really tough experience for customers. But here, good in Walmart, we have almost like 9 to 10 types of promise. So so like I think you know delay for 5 or 10 minutes uh, a bad thing. But if you promise too much, it's really a bad thing. Yeah. So manage the expectation about your leadership and your customers is really important. Yeah. Mm-hmm. This is a really big topic. Yeah, yeah, yeah. I think this is from different perspective from transportation or delivery part. I think we really look at like transportation related or promise related data, and again we have some other like merchandising or operations or commerce departments. They have their different focus on. Uh, uh,
They track all like what you have purchased, when, how frequent, etc., etc. Right? They also look at um, yeah. So if, for example, if you are considering leaving the services, then possible this products that will lead some unsatisfaction, right? When you return means you are not satisfied with the product that they sold. Another thing is probably for a long time you didn't use their service to purchase anything, right? All these could be the signals, and they try to look at your pattern and detect anomalies to see if something abnormal happened, which is Yuan described, right? Using different methods to detect the anomalies. If that happened, then they predict is it normal. They also need make a judgment. Is that because you changed your living location, or if you travel abroad or something, right? And if they can exclude out those causes, then the one left is that you're not interested in using the service anymore, right? So you collect all data to understand the pattern and detect anomaly, and then find out what are the root causes of the anomaly, and then leads to you are possibly leaving the service. Yeah, just that's a general explanation. All right, so thank you very much. Thank you, Yuan, for delivering this presentation, and I think it's very give us lots of kind of big picture about how logistics and transportation could be used in different sectors. So thank you so much. And also thank everybody for being here. Thank Ken for the questions and the comments. And thank Elena for showing us your dog. That's a lovely dog. Elena, just for your information, all our presentations actually recorded and it will be put on the social media. Okay. All right. So next week, actually, I will be the presenter. And I think, Ken mentioned about advanced air mobility, urban air mobility. That will be the topic that I will discuss next week. So I hope to see everybody there. Okay. All right. That's all for today. Thank you again. Thank you.